So when we're dealing with radicals and simplifying radicals from outside in, so if we're making a whole radical or entire radical, outside in we power. And from the example above in green, we're doing inside out. So we're taking factors from the inside to the outside. We root. So that 36, the 36 here inside becomes a 6 on the outside. So doing this process for these examples, we want to find perfect squares. So in the case of 200,000, we can find a perfect square of 10,000 and then we can multiply that by 20. So 10,000 really is 100 squared. And then we can keep breaking this down. Now we don't have to start with the biggest. We can always break it down further. So even in this case here, although we found a really big perfect square in 10,000 squared, or sorry, 100 squared, there still is a perfect square in the factor 20. So I'm going to take that out. There's this perfect factor of 4, perfect square factor of 4 we have to take out. So we're going to take those out. So we're going to start taking the perfect squares out. I can take them all at once or I can do them separately. So I'm going to take out the 100 first. And I'm left with 2 squared times 5. And then the 2 squared comes out on the outside. So we end up with 100. Times 2 comes out on the outside, and then we're left with 5. Okay, so I'm just going to color code some of this. That 100 here comes from that. Okay, we have another perfect square factor of 4. It ends up here and ends up there. So that's where all those parts come from, and the 5 is left inside because that's a non-perfect square factor. So looking at 50,000, now we have to look for perfect powers of 4. So in this case here, we can write 10,000 as 10 to the power 4, and then we have times by 5. Okay, so 10,000 becomes 10 to the power 4. Maybe I'll just do this in a couple steps here. So we end up with 10,000. Okay, that is 1 with 4 zeros, so that can be rewritten as 10 to the power 4. That is a perfect power of 4. So that can come from the inside, and that can end up on the outside. So the 4th root of 10 to the power 4 becomes 10, and on the inside is whatever cannot come out. So that's where the 10 comes from. It comes from the inside out. For this one here, we look at the index. It's a cube root index, so we're looking for perfect cubes. Okay, so I'm just going to count. This is I can express this in a power of 10. So we've got 1, 2, 3, 4, 5, 6, 7 zeros. So I'm going to write this as 10 to the power 7. Okay, so 7 zeros gives us 10 to the power 7. Now I want to look for perfect cubes, so I can write this as 10 to the power 6. 10 to the power 6 is a perfect cube, times that extra 10. If I cube root, again I want to just keep track of that. If I want to cube root that 10 to the power 6, I end up with 10 squared, which is 100 on the outside, and that extra 10 on the inside has to stay inside. I'm just going to put brackets around this too so that we don't mix that up, and then we can also just express that as 100 on the outside and then cube root 10 on the inside. For D, we're looking for perfect cubes again. We're looking at that index. Well, I'm going to first of all take out that 125 because I know that is a perfect cube. So I can do this in steps. 125 times, that's going to be 10,000, like that. Okay, so I can split this up even more. I know 1,000 is a power 10 to the power 3, so I'm going to factor out the 1,000. So I'm going to first of all convert that to 5 to the power 3. And then I'm going to factor out a 1,000 times 10. And that 1,000 then is going to be, that's going to be a perfect cube as well. So taking that 5 to the power 3 out, so when we take inside out, we root. So I'm going to take the cube root. I'm going to write that 1,000 as 10 to the power 3. Okay, that 10 to the power 3 is also a perfect cube. So that needs to come out on the outside. So I end up with on the outside 5 times 10. And left on the inside is that extra 10. So that's where that 5 comes from there. And this 10 comes from that 10 to the power 3 or 1,000. So you can kind of trace that back to see where that all came from. And so finally, I'm just going to write this as 50. Combine that together into 50 on the outside. And the cube root of 10 is going to be left on the inside.